Alabama's East Alabama.
You know, that virus was first reported right here in Alabama, but now 25 states and territories are investigating cases.
Welcome back. Tonight, we take you deep beneath the familiar landscapes of Alabama, the green ridges, winding rivers, and sleepy southern towns, to uncover a wave of discoveries that have left the scientific world reeling. Recent breakthroughs across geology, paleontology, archaeology, and biology have prompted researchers to re-examine what we think we know about the state's ancient past. What scientists have uncovered stretches across time and discipline. Fossils dating to millions of years before written history, sediment layers hinting at ancient environmental upheavals, and seismic anomalies that challenge assumptions about the region's bedrock stability. Each find has attracted attention far beyond the state's borders, drawing experts from around the globe to survey what now may be among the most intriguing scientific terrains in North America. At the center of this storm of discovery stands a high school teacher, Alan, who, while working in Walker County's Union Chapel coal mine, discovered fossilized trackways distinctly different from those previously cataloged. This moment is not an isolated scientific victory, but a doorway to renewed exploration throughout Alabama. Archaeologists, geologists, paleontologists, marine biologists, and seismologists have begun to delve more deeply into a region that suddenly seems to hold more mysteries than answers. What do Alabama's strata and ancient fossils reveal about the early history of life on Earth? Could there be overlooked clues to prehistoric ecosystems or ancient climates in this modest landscape? Tonight, we break through the limestone and silt, delving into the top 18 discoveries that have sparked renewed interest in Alabama's prehistory. Just what did scientists find, and what lessons do their discoveries hold? Is it possible that the soil beneath our feet might contain the blueprints to both life's beginnings and its ongoing changes? Trackways in stone, the Union Chapel discovery. Our journey begins deep beneath Walker County in the tunnels of the Union Chapel coal mine. This site, previously regarded as a regional curiosity by professionals in search of richer ground, became the epicenter of paleontological excitement when Alan, a high school teacher with a persistent passion for fossils, unearthed tracks preserved in stone. Unlike the skeletal dinosaur remains famous in museum halls, these are ichnofossils, trace fossils in the form of trackways, burrows, and resting marks left by long-vanished organisms. The clarity and abundance of these Paleozoic tracks stunned both amateur collectors and academic experts. The fossil-bearing shale dates to the Pennsylvanian period, more than 300 million years ago, a time when vast swampy forests, not dinosaurs, dominated the land. Within these layers, tracks of early amphibians, arthropods, and mysterious invertebrates are pressed into rock. The sharpness of these prints, sometimes showing delicate toe impressions or body drags, reveals a surprisingly rich and dynamic ecosystem. Some trackways suggest intricate behavioral patterns, such as hunting or social movement, challenging previous suggestions that the region was ecologically simple. The Union Chapel site soon became internationally celebrated among paleoichnologists, and its rich fossil beds provided new baseline data on the diversity of Carboniferous life. What stands out most is not necessarily a single track, but the cumulative record, hundreds of overlapping life stories captured in slabs of shale. For researchers, this fossil record is not just a window into Alabama, but a key to reconstructing ancient global ecosystems during the rise of vertebrates and the earliest large-scale colonization of land. Beneath the Gulf, anomalies along Alabama's coast. While headline discoveries originated inland, equally compelling scientific pursuits are underway just off Alabama's Gulf Coast. New mapping technologies, multi-frequency sonar, remote-operated vehicles, and improved seismic imaging have begun to reveal the complexities of the undersea geology off Mobile Bay and the wider Gulf Shelf. Researchers have identified extensive ancient river channels and submerged landscapes that date back to periods of lower sea level during the last ice age, when what is now the Gulf of Mexico shoreline was dozens of kilometers further out. While some have speculated about geometric structures beneath the seabed, the current consensus is that the labyrinths and passageways imaged are products of ancient erosion, not evidence of human activity or lost civilizations. More intriguing, from a geological standpoint, core samples from the seafloor reveal evidence of dramatic changes in climate and hydrology over tens of thousands of years. Sediment bands indicate sudden freshwater influxes, periods of high productivity followed by drought, and occasional layers of tephra, volcanic ash, likely originating from distant eruptions in other parts of North America. Seismic studies have outlined complex salt dome formations and fault structures that occasionally trigger low-magnitude tremors and can influence coastal groundwater movement. There is no direct evidence of undersea cities or intentional design beneath Alabama's current Gulf shoreline, but the real scientific astonishment lies in the preserved record of environmental change and the reminder of how dramatically Earth systems can alter coastlines over geologic time. The shadow of the Megalodon, prehistoric sharks in Alabama. Alabama's rivers and ancient waterways hold another chapter in the region's history, the story of enormous prehistoric sharks. While the famous 1705 fossilized tooth found along the Hudson River was once misidentified as a giant humans, Alabama's own fossil record includes finds of megalodon teeth and other marine predator remains, confirming the presence of these massive creatures in the state during the Miocene and Pliocene epochs, millions of years ago. Megalodon teeth found in Alabama are generally recovered from riverbanks, gravel pits, and marine sediment outcrops, and sometimes measure over 6 inches long, bearing the telltale serrations of the world's largest known predatory shark. At the time these teeth were shed, much of Alabama was submerged beneath shallow seas teeming with life. As sea levels changed and sediment accumulated, many of these shark teeth were buried and preserved, only to be exposed in recent centuries by erosion, mining, or deliberate paleontological search. The fossil record indicates Megalodon and other prehistoric sharks migrated throughout the region, following ancient coastlines and prey. The presence of Megalodon in Alabama is not unique. The species is found in fossil beds around the world, but each new find adds to our understanding of ancient marine ecosystems and changing sea levels. Forgotten civilizations hidden in plain sight. Alongside natural history, Alabama is rich in archaeological sites attesting to millennia of indigenous occupation and ingenuity. Large earthen mounds, village remnants, and artifacts reveal the existence of organized societies with extensive trade and ceremonial traditions, notably during the Woodland and Mississippian periods. Using modern tools such as LiDAR and aerial photography, researchers have detected formerly hidden patterns of habitation, mounds, earthworks, and alignment of post holes in river valleys and forested areas. While the shapes of some ancient structures might at first seem geometric, there is no verified evidence of lost high-tech civilizations. Rather, these findings confirm the resourcefulness and complexity of Native American cultures that engineered landscapes for ceremony, habitation, and agriculture. Artifacts from sites like Moundville display advanced craftsmanship with pottery, shell beads, and tool fragments from distant trade partners. Occasionally, pottery and artwork display symbols or motifs that remain untranslated, hinting at the cultural depth and interconnectedness of these societies. Abandonment and transformation of settlements, whether from climate, social upheaval, or contact with European colonizers, mark the shifting fortunes of people across millennia, a story visible not in vanished temples, but in the enduring marks made on Alabama's land. The rumbling beneath Alabama's hidden earthquakes. While rarely in the public consciousness, Alabama is not immune to seismic activity. Minor earthquakes occur with some frequency, especially in the northwest part of the state near established faults. Improved monitoring in recent years has detected deep earth movements and localized tremors, some with epicenters far from known fault lines. The debate remains over the origins of some low-frequency seismic events. Some research suggests these are driven by deep tectonic stresses in the North American crust, while others speculate that modern industrial activity might occasionally play a secondary role. There is no current evidence of active magma chambers or impending volcanic eruptions in Alabama, but geophysical surveys do sometimes reveal anomalies, hotspots, or conductivity shifts, which may relate to deeply buried geological features. Regular seismic monitoring continues, both as a scientific enterprise and as a matter of public safety. Any increase in seismic activity is closely studied to assess risks to local communities and infrastructure. Lakes of Memory, Geological Time Capsules. Alabama's myriad lakes, some natural, others man-made, are invaluable timekeepers in the state's environmental story. Scientists analyzing sediment cores from old lakes have compiled detailed records of climate change, wildfire events, and vegetative succession stretching back thousands of years. Each layer in these sediment cores contains pollen, charcoal, microfossils, and ancient DNA, acting as a page in the ongoing history of the state's ecosystems. The record reveals cycles of warming and cooling, evidence of extensive fires, and transitions between forested and more open landscapes. In some cases, abrupt changes captured in the core coincide with broader climatic events, such as the end of the last ice age. Occasionally, trace levels of heavy metals or volcanic ash in sediments offer clues about regional and global events, such as distant eruptions blanketing the South with fine particles. In recent years, DNA analysis from undisturbed sediment has revealed extinct plant and insect populations that once thrived, providing context for evolutionary adaptations and ecological shifts. These natural time capsules help researchers better understand both the resilience and vulnerability of Alabama's environments. The river that forgot. Alabama's changing waterways. Waterways have always defined Alabama's landscape, but the configuration of rivers, lakes, and floodplains has never been static. Sediment and core studies, combined with precise mapping, show that major rivers, such as the Coosa, Tallapoosa, and Tennessee, have shifted courses, sometimes dramatically, over tens of thousands of years. Floodplains exhibit signs of ancient courses and cutoffs, now dry. Analysis of these deposits reveals changing flow rates, periods of flooding, and episodes of drought, all linked to broader climatic changes, or, at times, seismic events. These shifting watercourses have affected plant and animal dispersal and influenced patterns of human settlement. In some areas, paleontologists have found river sediments rich in marine fossils, confirming that areas now far inland once lay beneath ancient seas. In others, black bands of volcanic ash trace the distant echoes of northwestern U.S. eruptions. Such records echo a broader truth. Landscapes evolve continuously, and what appears permanent may merely be a fleeting chapter in a much longer story. The unseen volcanoes, sleepers in the earth. Although Alabama today is seismically quiet and has no active volcanoes, its deep geological history includes evidence of ancient volcanic activity. Bedrock studies in parts of the region have identified solidified igneous bodies, intrusive dikes, and ancient volcanic ash layers, remnants of eruptions dating back hundreds of millions of years when the continent's interior was shaped by tectonic rifting. Some of these ash bands contain heavy metals and minerals that affected soil chemistry and may have contributed to extinction patterns observed in the fossil record. Modern geothermal gradients and subtle anomalies occasionally turn up in geophysical investigations, but there is no recognized threat of renewed volcanic activity. Instead, these ancient volcanic features are important for reconstructing the continent's tectonic evolution and understanding the large-scale forces that shape the land. Plants from other ages, secrets in the soil. Alabama's coal beds, formed in the Carboniferous period, are a goldmine for plant paleontologists. Within seams of ancient peat, researchers routinely find beautifully preserved fern leaves, horsetails, lycophytes, and seed ferns, some species extinct since the age before dinosaurs. Fossil spores and pollen, extracted with modern techniques, provide further insight into plant evolution, community turnover, and environmental changes. Occasionally, unique plant fossils or pollen types turn up, revealing lineages with no modern descendants. These ancient findings help reconstruct evolutionary chains and illuminate how ecosystems responded to ancient climate shifts, glaciations, and fires. The deep connections between geology, climate, and biology become clear. Ancient swamps left not only coal, but also the genetic and ecological blueprints for later generations of life. The animal tapestry, ecological mysteries. Beyond the coal mine, fossils, and lakes, Alabama's caves and gravels preserve a wealth of animal remains from periods reaching back tens of thousands of years. Fossils of mastodons, giant ground sloths, saber-toothed cats, and enormous prehistoric birds have been discovered in caves and riverbanks. Analyzing these remains, scientists have detected evidence for repeated invasions and extinctions of large mammals, often coinciding with climatic upheavals or human arrival. Hair, teeth, and bone fragments occasionally yield ancient DNA, providing timelines for species extinctions and introductions. These findings reinforce the idea that Alabama's fauna has always been dynamic, shaped by migration, climatic stresses, and episodic catastrophe. Modern biodiversity still reflects this legacy. Remnant genes, displaced lineages, and adaptive strategies all trace back to prehistoric survivors of fire, flood, and cold. Seismic architecture, the quake that rewrote history. Just over Alabama's border in Mississippi, major fault line and collapsed cave systems have been mapped, with some running toward and into northern Alabama. Sediment analysis and ground-penetrating radar have linked these ancient fault movements to changes in river courses and localized land subsidence. Though most of Alabama's present landscape bears no visible scars of major earthquakes, the geologic record reveals intervals of sudden disturbance, compressed sediments, tilted rock strata, or mass movement deposits. The land's memory is recorded quietly beneath our feet, a warning that seemingly stable ground may have a more eventful past than meets the eye. The archaeological enigma, imprints of the unknown. Allen's discoveries in Walker County continue to fuel debate and research. Some trace fossils from Union Chapel are difficult to categorize, but while their exact makers remain unknown, there is no verified evidence of pre-human or human tool use dating to the Carboniferous in Alabama. Most scientists attribute ambiguities to ancient animal activity, not intelligent design. The site, however, remains one of the world's most important localities for Carboniferous trace fossils, and further discoveries continue to refine our view of this ancient period. The secret in the clay, ancient fires, and buried carbon. Central Alabama's clays chronicle an environmental record of fire and rebirth. Charred plant material and black carbon seams within sedimentary layers indicate periodic intense fires, likely ignited by lightning, or, in rare cases, more dramatic forces. Microscopic examination of these materials helps reconstruct the region's fire regime, linking it to ancient drought cycles, or, in some cases, the influx of volcanic ash. Plant remains trapped in these layers often provide insight into post-fire ecological succession and underscore the resilience of life in the face of repeated disturbance. These records are a testament to the cycles of destruction and recovery that have characterized the region's ecology for millions of years. The hidden technology, sensors, and secrets. Recent advances in sensor technology and analytical methods have revolutionized the study of Alabama's landscapes and fossil beds. Geologists and biologists are deploying soil moisture probes, seismic sensors, and chemical detectors across key sites, yielding data on everything from groundwater movement to magnetic anomalies in bedrock. Such tools help identify new fossil localities and potential archaeological sites, as well as monitor ongoing shifts in subsurface stability or chemical composition. They cannot, however, detect lost civilizations or solve every mystery. They are valuable tools in building a clearer, evidence-based portrait of Alabama's deep past. The threat to water, an invisible danger. Alabama's groundwater system is vital to millions. Much of the region's drinking water is drawn from aquifers that pass through ancient, occasionally fractured rock. Concern arises whenever seismic or subsurface shifts threaten to open new pathways between surface contaminants and deep aquifers. Researchers and environmental managers remain vigilant, monitoring for early warning signs of pollution or sudden changes in water quality. The lesson is simple but profound. Alabama's underground resources are intimately connected to the shifting geology above and below, and our stewardship must be informed by both modern technology and lessons from deep time. The echoes of extinction, a region marked by loss. Over the eons, Alabama has witnessed repeated cycles of species extinction and ecological renewal. Fossil-rich strata tell of sudden die-offs, perhaps from climate swings, invasive species, or massive fires, followed by periods of dynamic adaptation and rediversification. Archaeological sites carry the story into human times, with evidence of shifting habitation, subsistence, and environmental change. The message is not one of unremitting catastrophe, but of resilience. Seed banks protected by geology, new species arising from the survivors, and human societies responding creatively to the challenges of a changing world. The questions left behind. As investigations continue, across disciplines and generations, one truth emerges. Alabama is a crossroads of ancient life, catastrophic forces, and creative adaptation. From the trace fossils left by early amphibians to the subtle shifts detected by modern sensors, the state's land and water hold unanswered questions as well as clues. For every mystery resolved, more arise. Which stories wait still to be revealed in the layers beneath our feet? Which discoveries await the next curious collector or patient researcher, driven by questions that stretch backward across the eons? If tonight's journey through Alabama's mysterious past has inspired you, don't forget to let us know. Which of these discoveries caught your imagination or left you with new questions? Your curiosity and engagement could be the spark that drives new inquiries and keeps the story of Alabama's ancient world unfolding for generations to come. Thanks for joining us, and until next time, keep exploring and keep asking questions.